guys, Half Power here. You're going to need a graphing calculator, and I would suggest that you pause and type these in and make sure you're getting the same graphs. But to make the video shorter, I did insert most of the graphs already. All right, so a power function is a monomial function, okay, which means it only has one term. We're not talking like a quadratic. It's any form, when you can write it as a time any function, you can write in this form, where a can't equal 0 and n can't equal 0. So it could be a constant function. I'm kind of confused because wouldn't that mean n had to be 0? Anyway, it just says a monomial function could be, and a constant function would look like this, like y equals c. We're not going to have constant functions anyway. A linear function like y equals x would look like this. Y equals x squared would look like a parabola at the origin. Y equals x cubed. Now this one you need to memorize the shape if you don't already. It's down on the left and up on the right. Think about when you put ordered pair in here. You put in a 1, you get out a 1. You put in a -1, you cube it, you still have -1. Okay, so it's in quadrants 1 and 3. A quartic would be degree 4. And it looks just like a parabola, except it flattens out a little bit more at the bottom, but basically we'd never know the difference. It's a parabola. Y equals x to the 5th looks like a cubic, except it also flattens out here a bit more, but you'd never know the difference. So what we're trying to get to here is that degree 3, degree 5 are very similar shape. Degree 2, degree 4, very similar shape. Okay. We talked about symmetry. Remember this? This was back in chapter 1. If a function has an even power, it will be an even function, meaning it will have y-axis symmetry. If it's an odd power, then it will have odd or origin. It will be an odd function, which means origin symmetry. That's only true when you have the monomial or the power functions. Once you start adding in other terms, like if you had an x squared plus 2x minus 5, and your parabola was, over here somewhere, then it does not have y-axis symmetry anymore. So when you start transforming them, they are not strictly even or odd anymore. All right. So just to look at these one more time. This had origin symmetry. It was odd. Whoops. This one was odd. This one was odd. They all had origin symmetry. This would actually be even as well because it would have y-axis symmetry. And this one would be even. Just talking about symmetry as well as the exponent power. All right, the end behavior is determined by the power and the coefficient. So when we have an even power and a positive coefficient, both ends go up. Okay? Now, we got to remember how we write that. End behavior, this means y is infinity means up, and y is also up, on the left and the right. So this means up and this means up. And then when we say as x approaches negative infinity, that one means left. And as x approaches positive infinity, as the x goes off to the right, we say positive infinity. So just to review those words, the y being up, because they're positive infinities. X goes left to right. Negative would be over here. That's a negative x as you go off that way. A positive x as you go off that way. Okay, so the negative infinity for x is left, positive infinity is right. All right, I'm going to cheat a little bit and write these a little faster. This one has both ends down. Think about that when you put the negative out there, it flips it upside down. I wrote that too close. Okay, so if we're doing this one, now both ends are down, so y is negative on the left, and y is also negative on the right side. All right, when you have an odd power, you have odd function, which is odd symmetry or origin, as long as it's a monomial, okay? If it's a positive coefficient, the left end is down, and the right end is up. Okay? So to say that, we say down, y is negative on the left, as x gets more negative, and y is positive or up as x gets more positive or goes to the right. And then it flips if you have a negative out front, so it's left up and right down. Now, to write left up, I say y is going up as x gets more negative. And then I say y is getting more negative as x goes to the right or gets more positive. So think hard about those. They have to mean something to you. If you're just writing random infinities, you need to talk to me and get some help so that we're not struggling with in behavior, because it's really important. All right, so we're going to fly through some examples here. There's quite a few examples, so I went ahead and typed them in. This is a degree 6, I can't see. And it has a positive leading coefficient, so I typed it in my calculator. This is what it looked like. If I put in a 0, I get out a 0. If I put in a 1, I get out a 3. And a negative 1, I get out a negative 3. So it's very much like a parabola. It's a little flatter down here. I didn't do a very good job, but all right, so the domain is what can you put in for x, and that can be anything. We could write all real numbers, or we could write negative infinity to infinity. The range, though, is bottom to top, and that is 0 to infinity, and it does touch 0. All right, x-intercept is 0, 0. Y-intercept is 0, 0. Increasing. Well, this graph, as we go left to right, remember, this side is going down, this side is going up, left to right. Hope you remember that from last week. All right, so the increasing interval started here at 0 and to the right, and we don't ever need brackets when we do increasing and decreasing. The decreasing interval was the negative side, so from negative infinity to 0, because we're giving x intervals. We're talking about what x values make it decrease or increase. The symmetry is with the y-axis. It has no discontinuities, and both ends are up. So y is approaching infinity on both the left and the right. right, pause the video anytime. I'm trying to go fast because these are not super exciting. This is odd degree, so the ends are going opposite direction. It is a negative leading coefficient, so therefore it's coming from here and going down over here. If we put in a 0, we get out a 0. If I put in a 1, I get out a -2. If I put in a -1, -1 to the 5th is still -1 times -2 is 2. So it's doing this. If I put in a 2, by the way, I'd get a super big number, like a -64 or something. That's why it looks like it's almost going straight up and down here, but it's not. All right, domain is, you can put anything in and get anything out because it gets wider and wider, though very slowly, as it goes left and right. That would be domain, and it goes up and down forever. That would be the range. It goes through 0, 0. Now, the whole thing, as we're coming over here, the y values, I'm sorry, as the x's go to the right, the y's are getting smaller and smaller. The whole thing is decreasing. The symmetry it has is with the origin. It has no discontinuities. All right, and then we have to say on the left, that's an L for left, just to remind you, okay? It is going up. On the right, it is going down. Got it? All right, a rational function, remember x to the -1 is the same as 1 over x. And when you have a rational function, there's going to be places where the denominator is undefined, okay? Denominator has an x, so you're going to have some discontinuities. A power function with negative exponents are undefined whenever x is 0. You can't put in a 0, okay? X cannot equal 0. So here's one that has a negative, x squared. So you could write this in your calculator as either 4x to the -2, which I happen to have saved that one to show you. Here's 4x to the -2, and then I wanted to show you it is the same as 4 divided by x to the +2. So I graphed the first one in blue and the second one in red, and if you watch, the red just went right over the top, okay? So it was blue and then it went over the top with the red. Now, what I wanted to show you, the reason I graphed this one at all and left it, was as I trace here to the right, some of you are going to think that this touches the x, but the x-axis. If you notice, the y is getting very, very small right here, but it doesn't ever become 0. It might round eventually if you went out enough places to 0 because of calculator error, but if you divide by a really big number, okay, so if we went out to 100, so we had on the home screen, if you did 4 divided by 100, and then it had a squared or a -2, so it would be squared here, or 4 times 100 to the -2. All right, same thing, 4 divided by 100 squared, or 4 times 100 to the -2. They give you this. Well, that's scientific notation for 1 over 10,000. Or 4 over 10,000. My bad, I wasn't thinking about that. So if I go out to 100, I'm still not getting 0 or a negative number. I'm getting a tiny little decimal, 4/10,000ths. So my point was, this doesn't ever touch, even though your graph looks like it does. If we changed our window for our y value, our x value, our up and down, that would be y, sorry, from -1 to 1, it would look, because we're looking at such a little piece of it, you can tell that it's not touching, okay? So that was just an example for you to see that even though it looks like it's touching, it's not. All right, domain, I can put anything in there I want, except what? There is a discontinuity. I cannot put in x equals 0. And that's all I'm going to write because there's not a lot of room here. The range, if you look here, it's going to stay above. We should have graphed it. Let's see, if we put a 1 in, we get out a 4. If we put a 2 in, we'd get out a 1. So there's a couple ordered pairs we could use, but it does get smaller and smaller here. I didn't do a very good job. And because it's a 4 over x squared, already wrote that up there, when you put this in, it's going to stay positive. So it's going to be over here. All right, I did a little better job drawing that one. The range is bottom to top, okay? Now there are y values all the way from 0 on up. Doesn't ever touch 0, but it goes up. X values have everything left to right except 0. The other way we could have written that one was everything up to 0 and everything from 0 on up, but no square brackets because you can't include 0. All right, it has no x-intercept or y-intercept then because it never touches. This branch is increasing and this branch is decreasing. So it is increasing from -infinity until 0. And then from 0 to the right, it is decreasing. The values are getting smaller and smaller. All right, symmetry is with the y-axis. If you folded this across, the blue would match up. It has a discontinuity at x equals 0. It's called an infinite discontinuity. You could just write x equals 0 is where the discontinuity is. All right, end behavior. As you go off to the left, the y values are actually getting closer and closer to a specific value of 0. And the same thing is happening on the right. As you go off to the right, the y values are also getting closer and closer to 0. All right, a couple more. This one also looks like it touches, but it does not. X to the -5, okay, is 1 over x to the 5th. So big numbers are going to get incredibly tiny. If we put a 1 in, we get out a 1. If we put a 1/2 in, we'd get out like a 32, I believe. So it is incredibly, quick growing and getting closer and closer to the x here. And I totally did that wrong because there was a negative out in front of it all. So all my values should have been negative when I put those in. That's what I get for not looking over there. So when I put in a 1, I get out a -1. If I put in a 2, I get out like 1/32. If I put in a 1/2, we'll get out -32. Okay. If I put in a -1, I'd raise it to the 5th down here and get -1, but this negative would make it positive. So the other branches up here, you're welcome to just use your calculator for these. All right, the domain left to right, it has a break at 0. So I'll write it like this, but you could have just written x cannot be 0. Range is the same, going up and down. It has values everywhere except 0. All right. It has no y-intercept or x-intercept. This branch is going up. This branch is also going up. Guys, if you were to trace out here, you'd get like 0.0001, 0.0002, 0.0003. It's getting bigger and bigger, and then it goes up towards infinity. Over here, you'd have negative values, but they get less and less and less negative, and then they stay just below the x-axis. So it is actually all increasing, but you do have to say except at 0 because there's a break. Increasing, increasing. The symmetry is y-axis. Just kidding. Oh my goodness, can I get this more wrong today? Let me shut my window. The neighbor's mowing. That's what you get when we record on a Sunday afternoon. You're not the only ones doing schoolwork on the weekend, guys. Okay. This has origin symmetry. If you turned this graph 180 degrees, it would look exactly the same. All right, it is discontinuous when x equals 0, because that's the domain restriction. And the end behavior, okay, on the left, this is getting closer and closer to 0. On the right, it is getting closer and closer to 0. Now, once it's getting close to 0 from above, once from below, but those are things you'll talk about in calculus. All right, I started this slide for you. Power functions with rational exponents. This means fraction exponents, okay? Usually we say that as fractional exponents, can be written in radical functions, as radical functions, okay? Now there's two ways you can write this. The bottom number is always the root. Can go here. The top number, the m, can go inside the radical or outside the radical. All that means is if you have, let's put x to the 3/2, okay? It means the square root of x and then cubed, or cube x and then take its square root. The order of operations doesn't matter on this case because you're going to do both, okay? When n is even, the bottom number, the domain is restricted to positive value. The bottom number here, which means it's a square root or a fourth root. So you can't take the square root or the fourth root. Only positive numbers can go in here. But remember, if you have a cubed root or a fifth root, something like that, then you can have positive or negative numbers in there. All right, sorry, I kind of got flustered in the middle of that. All right, so this x to the 1/4 really means the fourth root of x. I put it in both ways here. Can't tell. I put in x to the 1/4. Oh, without the parentheses. This is because if you have an older calculator and you don't get that little box, your calculator will look like this. X to the, and then, whoops, has that little caret key. All right, let me try that again. If your calculator is older, you will type x to the 1 divided by 4, but it will not do that correctly unless you put parentheses around the 1/4. If yours doesn't go up into a little box up there as you're typing, then you need the parentheses. Now, I will tell you there is a way to do a fourth root of x too, but this was written as 1/4, so we won't worry about it. Under the math menu, there's an x root of, and then you could type in this little box and you could put a 4. All right, I'm going to run through these. I feel like this video is already getting long. It does go through 0, 0. If you put a 1, the fourth root of 1 is 1. The next nice one is like 16. 2 to the fourth, 2 times 2 is 4, times 2 is 8, times 2 is 16. So you'd be all the way out at 16 before it would hit 2. So it is very slowly growing, but it does continue to grow. You can only put positive numbers in here, so this is 0 and up, and you will only get positive values out, but it will continue to grow ever so slowly. It has an x and y intercept at 0, 0. The whole thing is increasing, but it's only from 0 to the right. It's the only place it exists. So you have to give that x interval. Symmetry is none. Okay. If we turn it 180, it'll be down here. And it doesn't have a branch on either side of the y-axis. It is not considered discontinuous. It just doesn't start until here, but it doesn't have a break once it gets started. All right, the end behavior, this is kind of weird, but on the right, the value is increasing. But it doesn't really have a left. We could say as x gets closer and closer to 0, y will also get closer and closer to 0. This would be what it's happening on its left side. Okay, as you go further and further left, the x is actually getting close to 0, and so is the y. That's a weird one. All right, I think this might be almost our last one. Maybe it is our last one. 1/2, I put that in parentheses, and then I did x to the 1/5 power. If you put a 1 in, you get out a 1/2. If you put a 2 in, you still get out a very tiny number. Look at these numbers. Okay, all the way out at 1,000 and something, I'm just over 2. It only ever goes just over 2. It does keep going though. It's getting more and more and more. But this is a really bad, no, I'd have to be out at 1,000 before it goes over 2, okay? In our little window here, it's gonna stay below 1. And this way. But I do want to show you, it does go above 2 eventually, but it just barely keeps growing. All right, domain, we can put anything in there. And range, believe it or not, in theory, you could get anything out. To get a big number out, yeah, I can't even think how you'd get a very big number out of that. All right, an x-intercept is 0, 0, and the y-intercept is 0, 0. And it just barely, but it is getting closer. My graph is not showing that well at all, but if you look over here, it's getting just a little higher, and then it goes through 0, 0, and then it keeps growing just ever so slowly. So it is all increasing and never decreasing. It is symmetric with the origin. Okay, and it is has no discontinuities. It is going down on the left ever so slowly. And it is going up on the right ever so slowly. Okay. I can't even think how you would get a very big number out of that. If we just went to the home screen and we did 1/2, and then we put in a really big number to the 1/5 power. We're up to 79, so it does keep going, just ever so slowly. All right, is that the last one? Oh dear Lord, we aren't even done. We have to talk about a radical form. They can also rewrite, this is the equivalent to, by the way, guys, x to the 2/3, okay? So I have one example here where they wrote it in radical form. Same thing. So x squared, that's going to make it a positive, okay? You can put anything in there and square it, so the domain is all real numbers. But when you do that, you're going to square it and make it positive. Then when you take the cubed root of a positive number will be positive, but then there's that negative out in front, and that's why all the values turn out to be negative. All right, if you put a 1 in, you get out a -1. Put a 0 and you get out a 0. I think a nice number, let's see. If I put an 8 in and squared it, I get 64. And the cube root of 64 is 4. And then there's that negative. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. This is what it's doing. And you could, again, just type it in the calculator and check a value. If you go out here to 8, it's down at -4. And you are not going to be asked to be super accurate on these, I promise. Now, domain left to right is all real numbers, but range, the bottom, it can be as negative as you want, but it does come up and touch at 0, 0. So the top of the graph is at 0. For the y values, range is y values. Okay. X-intercept and y-intercept are at 0, 0. It is increasing and then decreasing. So it is increasing from the left. And when we get to the right side, it is decreasing. It is symmetric across the y-axis. It has no discontinuities. All right, on the left, the y value is going down, so we say -infinity. And it is also going down towards -infinity. On the right, which would mean x is going towards infinity. All right, I think that was my last one. Whew. All right, guys, I think I assigned 4 of these to graph with an extra one if you wanted to do it on a worksheet. So check out those and make sure you check your answers because this can be tricky.